All right. Okay. So we're going to start off with a little review of fractions. Yeah. Okay. Because today we're going to look at exponents that are fractions. They're called rational exponents and what they look like in a couple different forms and how to simplify with them and all that fun stuff. Okay. So we have to know what we're doing with fractions to begin with. So I'm going to ask you guys to go ahead and work together with your groups on those first 6 problems. Okay, the first 6 problems, go ahead and talk them through with your partners on how to add, subtract, multiply exponents. Ready, set, go. Okay, so how do we add fractions? Do we have to have a common denominator to add? Yeah. Yes, we do. On number 1, we have a common denominator. So 2/3 and 5/3 make 7/3, right? The denominator stays the same. I just add straight across the top. Okay. Number 2, do we have a common denominator? Whoa, what did I just do? Okay. We don't. So we need to make a common denominator. So 4 and 2 could both become 4. So I'm just going to leave the first fraction as is. I'm going to multiply the second fraction. So to make this a 4 on bottom, I have to multiply by 2 on bottom. So I got to multiply by 2 on top. So 3/4 is going to stay the same, plus now this is going to be 2/4. So that makes a final answer of 5/4. Okay? All right, subtraction, do we have to have a common denominator? Yes, we do. Again, just like we did on number 2, we're going to have to create common denominator here. So 2 and 3 both, what can they become? 6. So I'm going to have to multiply by 3 on the first fraction. So do the same to the top. Excuse me. I'd have to multiply by 2 on the second fraction. So do the same on top. So I would have 9/6 minus 2/6 is 7/6. All right. Cool. Sorry if this is boring to you. Just wanted to do it just to make sure we're all good on the same page. 4 and 5, what can I make them both? 20, so multiply the first one by 5, second one by 4, so I have 5/20 minus 12/20, 5 minus 12 is going to be a negative 7/20. Okay, multiplying, do I have to have a common denominator? No, I don't. Okay, so I just multiply straight across, so 1 times 4 is 4, 2 times 3 is 6. Make sure you're always reducing your fractions if you can. So both of those are divisible by 2. So that would become 2/3. Okay. What if one of them is not a fraction? Yep. Make them a fraction how? Put it over 1. Okay, perfect. So 2 times 3 on top is 6. 3 times 1 on bottom is 3. 6 divided by 3 is the final answer of 2. Okay, comfort level on fractions. Awesome. Glad to see you're all comfortable because that's like something you learned in, I don't know, 2nd grade, something like that. All right, now let's actually put this to practice, okay? So we're going to look at things today called rational exponents or rational powers. Okay? So this looks kind of sort of confusing, right? Exponential form and radical form. Hopefully it's not too bad. Basically, what you're looking at here is you're going to have some kind of base. So let's put some numbers to it. So say we have a base of 2. Okay? So just put this little number example right next to these two. So say we have 2, and we're going to raise it to the 3/4 power. Okay? So 2 raised to the 3/4 power. The base, so if I'm turning it from exponential form to radical form, the base is going to stay the same. Whatever the numerator of the fraction is goes inside. So that would be to the 3rd power. And then I'm going to put the little square root symbol here. And it's to the whatever root that's on the denominator of the fraction. So the 4 is going to go outside. Let me make this radical symbol a little better. There you go. Okay. So the base is always going to be the base, right? That part's the easy part. The top of the fraction stays inside the radical. You guys know that this thing's called a radical. Square root symbol is the same thing as a radical. That's why it's called radical form. Okay, so that whatever the top of the fraction is, here in this case 3, stays inside the radical. Whatever's on bottom of the fraction goes outside the radical. Okay, I'm not going to take a whole bunch of time explaining what that means right now. Next unit we'll look at radicals and we'll go a little more in depth into why that is what it is. Okay, but for now you just need to know how to go into radical form back and forth between radical form and exponential form. Okay. All right, so you have 4 try these, A and B. You're taking it from exponential form that is given to you, putting it in radical form. C and D, you're taking it from the radical form that is given to you and turning it into exponential form. Okay, so I'll give you a few minutes to do A, B, C, and D together with your groups. Go ahead. Okay, so on A, my base is going to stay my base. It's going to be raised to the numerator power, so that would be 2. And then my radical has the denominator on it, so to the 3rd root. Okay, on B, my base is going to stay my base. It's raised to the 5th power, and the root is the 9th root. Okay, so vice versa now. So my base is going to stay my base. The exponent inside's the numerator of the fraction. The exponent outside's the denominator of the fraction. So to the 7/4 power. It's kind of hard to say. Okay, base is going to stay the base. 2 is my numerator. 3 is my denominator. Okay, can I have a comfort level going back and forth between radical and exponential form? Cool. You guys are feeling good about that? That's good. So that right there is the only thing, really the only thing that's new today. Okay? It just gets kind of fun when you try to start doing your exponent rules with fractions. Okay, so let's do a little practice there. So let's look at 7 together. Okay, so they are the same base, so I know I can combine exponents. What am I supposed to do with exponents when I multiply 2 pieces together here? What? Add them, yes. Okay, so that means I need to add. So my side work here, I'm going to just put a little box or a little side work here. So I have to do 1/2 plus 3/2. So what is 1/2 plus 3/2? 4/2, which 4 divided by 2 is just 2. So this is my exponent work, right? So that means this answer is 2 to the 2nd power. Okay, exponential form is going to be 2 to the 2nd power, just like you know. There is actually no radical form here. Okay, if there's not a fraction left in your exponent, there is no radical form. So you can just put a big X on that, or a squiggle, or whatever. So you might just put a note, no rad form. Okay. All right, you guys do 8 and 9. I'll give you a minute to do 8 and 9. Go ahead. Okay, so you can check your work actually getting the exponents. Okay, I didn't want to bore you with going through all that over again. Okay, make sure you have common denominators. You can see my work there for my exponent. 8 ends up being 5 to the 11/6 power. 9 ends up being 3 to the 13/10 power. Do we have any questions on that specific part? We good? Okay, so the exponential form is just that, right? And then going into the radical form, the base stays the same. The numerator goes inside the radical. The denominator goes outside the radical. Base stays the same. Numerator goes inside the radical. Denominator goes outside the radical. Okay, any questions on that part? Cool. Let's move to, next page. Okay, let's move to division. So what do we do with our exponents for division? we subtract. Okay, so again, we're going to do our exponent side work. And we're going to subtract our exponents this time. So remember, we always do top minus bottom. So top minus bottom. So those are not or common denominators. So I'm going to leave the first one 10 and make the second one 10 by multiplying by 5 on top and bottom. So it's going to be 7 over 10 minus 15 over 10. So that's going to be, negative 8 over 10? Is it acceptable for any of our exponents to be negative? It's not. Okay? So instead of leaving it negative 8 over 10, we're just going to put it on bottom where it goes. So it's going to be 1 over 4 to the positive 8 over 10 power. So if you ever, excuse me, if you ever work one of these problems out and you end up with a negative exponent, remember that negative exponent just means flip. So instead of sticking it on top, I'm just going to flip it on bottom. So remember, this part tells you right here to flip. Just if you're looking back at your notes for future reference. The negative exponent tells you to flip. That's why it ends up on bottom there. Okay? So our exponential form is going to be just that, 1 over 4 to the 8 over 10 power. Okay, radical doesn't get any more complicated. It's just going to be on bottom. Okay? So we're still going to have 1 over, and then base stays the base. Numerator goes inside the radical. Denominator goes outside the radical. Okay? So that radical form is just going to have the same exact radical, the same conversion that we've been doing. It's just going to stay on bottom of the fraction. Okay? So if you're ever doing these problems and you run into a negative exponent, don't panic. Just put it on bottom. Okay? All right. Go ahead and do 11 and 12 together with your groups. I'll give you a couple minutes here. Do 11 and 12 together with your groups. Go ahead. Okay, you can go ahead and check your exponents work up on the board. So for 11, 3 halves minus 1 half is 2 halves or just 1. So my exponent's just 1. So it's 6 to the first power, which I can leave that in for exponential form. So what would my radical form be for this one? There's not one, right? So if there's not a fraction exponent or fractal exponent, there is none. Or you could put no radical form, whatever you want to do. Okay. For number 12, when I subtract my exponents, 1/3 minus 2/3, I get a negative 1/3. Remember, a negative exponent tells me to flip, so I get 1 over 8 to the third power. So that's going to be my exponential form. So then my radical form is not going to be not any majorly different when I flip it, or excuse me, when I convert it. I just leave that radical on bottom. So 8 is still the base. 1 is the exponent inside. 3 is the exponent outside. Cool. Any questions? Okay. So we have one more rule to go through, and then we might look at one of the really scary, nasty ones at the end. Okay. All right, so number 3. So this is power to a power, right? We have half of a 2. And I know this gets kind of weird to read, but we have half of a 2 written out 2/3 times, so that's kind of weird. So what are we doing with exponents here? We're multiplying, okay? So let's do our exponent work on the side, just like we have been. So we have 1/2. These are actually the easy ones, right? Because we don't have to worry about common denominator. Times 2/3. And we just multiply straight across. On top, 1 times 2 is 2. On bottom, 2 times 3 is 6. That reduces to 1 over 3. So we have 2 to the 1/3 power. So exponential would be 2 to the 1/3 power. What would my radical form be here? What's the base? Base is 2. What's my inside exponent? 1 is the numerator. And what's my outside exponent? Really, it's not. I guess that's not really an outside exponent. I shouldn't call it that because that'll get you guys into trouble. It's not an outside exponent. It's called a root. So like You know how when you say square root, there's not a number there? It's an implied 2. So this is actually called, because do you know how you read something when you see like x to the third power, you call it x cubed? Okay. If you see a 3 on the outside of a radical like this, it's actually called the cubed root. So instead of x cubed, then you have the cube root. And you have the 4th root, and the 5th root, and the 6th root, depending on what number is sitting out there. Okay. All right. That was just a little side lesson. Okay. So go ahead and do 14 and 15 together with your groups. I'll give you a minute here to do 14 and 15 with your groups. Go ahead. Okay, so you can go ahead and check your exponent work there. So I have 1/7 times 2 over 1 is 2 over 7. So that one's pretty straightforward on 14. 15 4/3 times 5 over 2 becomes 20 over 6, which then will reduce to 10 over 3. So always make sure you reduce as much as you can. So I have 4 to the 10/3 power. So obviously that's the exponential form for each of them. And do your best, I know it's kind of hard, especially on an iPad, to make the fraction look like an exponent and not like it's like 5 2/7 or something like that. Okay. So then radical form here would be 5 squared to the 7th root, right? 7's on the outside. And 4 to the 10th to the 3rd root. Okay. Comfort level on doing these different operations with fractal exponents, fraction exponents, rational exponents. Okay, so that's a good place to be. Okay, a little unsure, but that's okay. I know some of you already started 16. Let's look at it just for kicks. 16 is not that too awful bad. Okay, so let's just focus on the top for a second. Okay, so what operation is happening on the top? Multiplication. So what are we doing with exponents on top? Adding them. Okay. So top. So I'm just going to put top exponent so that I keep myself sane. Okay. I'm going to kind of organize stuff. So top exponent is going to be -1/2 plus 3/2. So -1/2 plus 3/2 is going to end up being just 2/2. Which is just 1, right? So on top of my fraction, it all simplified down to 3 to the 1st power, or just 3. So that's nice. Okay. Then we got to do the bottom. Okay, so let's do the bottom exponent. Whoa. What operation is happening on bottom? Okay, we're multiplying the exponents, right? Because it's power to a power. So we're multiplying the exponents. So I have 3/4 times -2 over 1. So that would be -6 over 4, which reduces to -3 over 2. What does a negative exponent tell you to do? Flip. So this tells me to flip. So where does that bottom piece need to go then? On the top, right? It needs to flip up to the top. So it's actually going to flip up to the top. So I'm going to put my little multiplication dot in here. This is going to be 3 to the 3/2 power. So there's actually no bottom to my fraction anymore, right? So I need to keep going, right? So there's step 1. So I'm done with all this stuff. Okay, now what do I need to do with exponents? Add them, right? So now my exponent, this time I'm going to add. So I have 1 plus 3/2. So that's like 1 over 1, right? So if I want to make a common denominator, I'd have to multiply by 2. So I would have 2 over 2 plus 3 over 2 is 5 over 2. So really all of this simplified down into 3 to the 5 over 2 power. Okay. So it's really It looks really scary because there's lots of fractions in there. But if you just take it piece by piece and step by step, it's really not that bad. Okay. So then we would have 3 to the 5 halves power, and that would be 3 to the 5th to the square root. If you want to put a 2 out there, you can, but without the 2, it's just an implied 2, right? So the square root's there. Okay.